Hello, I'm going to discuss the 9702 paper 1-2 of November 2025. The first question is, what is a reasonable estimate of the weight of an adult human? So the weight formula is W is equal to mg. We can have an estimate of the mass as 70 kilogram, and the acceleration due to gravity can be taken as 10 meter per second squared. So substituting these values gives you 70 times 10, which is 700 Newton, which is 10 to the power of 2 Newton. So the correct option is option B. Question number 2. What describes a set of data with a high precision? So the first option is data measured using equipment with small scale divisions. So this will improve the precision value, not exactly explaining a set of data with a high precision. So here the level of precision is high if you make several measurements of a quantity and they are all very similar. So a precise measurement when repeated will be the same or nearly the same value. So this can improve the precision value but not exactly the answer. The option B, data that is close to the accepted value. So this is explaining the accuracy, not the precision. Then option C, data with each value having low uncertainty. So this is also related to the precision but not exactly the precision. The option D, the data with repeats that are close to each other. So this is what exactly a set of data with a high precision looks like. So option D is the correct answer. Question number 3. Which physical quantity will have a unit of Newton second square meter inverse? So we have the options given. So in this unit you can find out the Newton is the unit of force and there is meters and second square. So option A is acceleration. So you can relate to the force formula. So F is equal to ma. So if you are rearranging it, A is equal to force divided by m. So that if you are converting into the units, force formula unit is Newton and the mass is in kilogram. So it's not a correct option. Option B, force. This is having just Newton. Then option C, it is about the mass. Again, you can use the same formula and rearrange the subject to be m. So F divided by A. So converting into the units, the force has newtons and acceleration has meters per second. So meter inverse second square. So the correct option is option C. Then again, momentum is having Newton seconds, not the Newton second square meter inverse. If you're really using this formula, force is equal to change in the momentum per time. Question number 4. A ball is released from rest. The distance the ball falls and the time the ball takes to fall, that distance are both measured. The percentage uncertainty in the measured distance is negligible. The percentage uncertainty in the measured time is 4%. The distance and the time are then used to calculate the acceleration of free fall and the air resistance is negligible. What is the percentage uncertainty in the calculated value of acceleration of free fall? So here it is given that it is released from rest, which means that initial velocity is 0 and the distance and the time is measured. So you have the s and the time value and you have to find out the acceleration. So in the equations of motion you can use the formula s is equal to ut plus half at square for finding the acceleration. Since the initial velocity is 0, ut will be 0 and s is equal to half at square. Upon rearranging, a will be equal to 2s divided by t square. So this is the formula that question is using and finding the percentage uncertainty. So you always add the uncertainties, you will never subtract. So here the percentage uncertainties is given, and if it is multiplied or divided, you should be adding the percentage uncertainties. So what is the percentage uncertainty of acceleration will be equal to the percentage uncertainty of the distance plus the percentage uncertainty of 2 is like 0 because it's a constant, and t square will be percentage uncertainty of time plus percentage uncertainty of time, which is basically 2 times the percentage uncertainty of time. So here it's given that the percentage uncertainty of the distance is negligible, so you don't have to consider this. So it is entirely upon the time percentage uncertainty, which is 4%. So 2 times 4, it is 8%. So the correct option is option C. Question number 5. A car has an initial velocity u. The car then moves with a constant acceleration a in a straight line through a displacement d. The car reaches a final velocity v. Which expression gives the initial velocity u of the car? These are the equations of motion. Since you have the initial velocity and the acceleration, the displacement and the final velocity, you have to choose the last formula, which is v square is equal to u square plus 2as. So here the distance is represented by d. So the subject should be the initial velocity. So u square is equal to v square minus 2ad. So u is equal to square root of v square minus 2ad. So the correct option is option B. Question number 6. A bicycle brakes so that it undergoes uniform deceleration from a speed of 8 meters per second to 6 meters per second over a distance of 7 meters. The deceleration of the bicycle remains constant. Which further distance will the bicycle travel before coming to rest? So we can split the question into two. First, the uniform acceleration. So the acceleration is a constant value, and the initial velocity is 8 and the final velocity is 6, and the distance it has traveled is 7. So meter per second, and it is meters. So here you can find out the acceleration, which is the constant value here, using the formula v square is equal to u square plus 2as. So rearranging, you will be getting 2as is equal to v square minus u square, and a is equal to v square minus u square divided by 2s. Substituting the values will be 6 square minus 8 square divided by 2 times 7. So you will be getting the value as minus 2 meter per second square. So this is the constant acceleration during the deceleration value. So it's minus, so it's representing the deceleration. Then after that, it will be moving with the speed. The initial speed will be the 6 meter per second square because it's decelerated to 6 meter per second, and the final velocity is 0 because it comes to rest. So the acceleration will be negative 2 meter per second square. So here you have to find out the distance, which is s. So again you can use the same formula, but you have to rearrange this one to get the distance. So it will be v square minus u square divided by 2a. So substituting the values as 0 square minus 6 square divided by 2 times minus 2. So after calculation, you will be getting it as 9 meters, which is option B. Question number 7. The velocity time graph for an object is shown. This is the graph. Which expression gives the total displacement of the object? So you already know that the velocity time graph area is representing the displacement, and the area above the time axis will represent the positive displacement, and the area below the time axis will represent the negative displacement. So if you have to find out the displacement, the total one, the positive area minus the negative area. So here the positive area is area 1 and negative area is area 2. So the correct option is option A. Question number 8. Which statement describes the weight of an object? So first option is, it is equal to the mass of the object multiplied by its acceleration. So mass multiplied by the acceleration is basically the force. It's not entirely representing the weight. So it's not option A. Then option B, it is equal to the resultant force when the object falls at terminal velocity. So if it is at the terminal velocity condition, the resultant force is 0 and the weight will be balanced by the drag force. So it is also not representing the weight of an object. Then option C, it is a force acting on the object due to a gravitation field. This is the correct option. So for the question number 8, C is the option. If you are checking the option D, it is a property of the object that resists change in motion. This is also wrong. Question number 9. What is a statement of the principles of conservation of momentum? So, as per the definition, in an isolated system where no external forces act, the total momentum remains constant. So here the first one is in an elastic collision, momentum is constant. That's absolutely correct, but this is not the principle of conservation of momentum. And here momentum is a product of mass and velocity. That is also correct. Momentum is equal to mass and velocity, but that's again is not conservation of momentum. Option C, the force acting on the body is proportional to the rate of change of momentum. This is basically the second law of motion, that is not conservation of momentum. But option D, the momentum of an isolated system is constant. This is basically the correct answer. Question number 10. The diagram shows the view from above of two balls moving a horizontal frictionless surface before they collide. The momentum of each ball is also shown. The balls stick together during the collision. Which vector diagram represents the combined momentum of the balls after the collision? So you could see this 4 Newton seconds is entirely to the horizontal direction. It will move in this way. You can use the triangular law of vector addition. So the resultant force will be in this direction. So it is represented by option B. Question number 11. A skydiver is falling at constant velocity. She then opens her parachute. The graph shows the variation with time of her velocity. So this is the graph. Which statement about the motion of the skydiver are correct? So the first statement is the magnitude of the acceleration is maximum at time t2. So here it is having an acceleration which is like it's a horizontal one. So always on a velocity time graph, the gradient is representing the acceleration. So at the point t1, the acceleration is 0 because it's of a horizontal line, and at t3 also the acceleration is 0. It's again a horizontal line, but at t2 it has a gradient downward direction, and it is the highest value at t2. Then it will get flatter. So it means that the magnitude of the acceleration is maximum at time t2 is a correct one. And the second point is the magnitude of the drag force at time t1 is equal to the magnitude of the drag force at time t3. So here at this point, it's having a acceleration 0, which means that the force is also 0. So the forces are balanced. There is no resultant force. So the weight is balanced by the drag force. So as the person opens the parachute, it has a decrease in the velocity. But even at this t3, the weight will be balanced by the drag force. Then only the resultant force will be 0, and it will be having a 0 acceleration moment. So the option 2 is also correct. Then option 3, the magnitude of the drag force is maximum at time t1. It is not the maximum. It has the value equal to the weight. So the third option is wrong. So only 1 and 2 is correct. So option A is the correct answer. Question number 12. Two different blocks P and Q slide towards each other on a horizontal frictionless surface. The blocks have an elastic collision. The diagram shows the velocities of the two blocks immediately after the collision. Which row gives possible velocities of the two blocks immediately before the collision? So here it is given that it's an elastic collision, which means it will follow these two conditions. So first one, the momentum will be conserved. The second one is the speed of approach is equal to the speed of separation. So here the speed of approach will be like they are moving towards each other. So it will be towards like this. And that velocities is equal to this. So speed of approach, if it is the u of 1, if you are taking the right side to be the positive and u2, the left side to be the negative. So the total one is u1 minus u2 will be equal to, so if you are adding, so it's a separation, so u1 minus u2 will be added, and that is equal to the speed of separation. So here also, since it is in the opposite direction, the values will get added, which is 70 plus 20. So the initial velocities will be added up into 90 is one of the condition. So if you are checking those options, the first one is adding 10 and 60. So it is 70, so it's not a correct option. Then 50 and 0, again a wrong option. 20 and 70, it may be an correct answer. Then 60 and 30 also may be a correct answer. Then we can go to the directions. P is moving to the left and Q is moving to the right initially, which is wrong. They are moving towards each other. So the option C is also wrong. Then option D will be the correct answer. So 60 centimeters per second to the right and 30 to the left. So the correct option is option D. Question number 13. Which diagram shows a couple? To form a couple, these conditions must be satisfied. They should be having forces of equal magnitude, parallel and in opposite direction. They must be separated with a distance. So here you could see this doesn't have an opposite direction, this doesn't have a force, and here they are not parallel to each other. So the correct option is option A. Question number 14. The diagram shows a uniform bar of mass m and length L resting on a pivot at a distance x from the end x. An object of mass m is placed on the bar at a distance y from the pivot so that the bar is in equilibrium. What is an expression for y? So here it is given that it is a uniform bar. If it is a uniform bar, the weight will be acting at the middle. So weight is acting at a distance L by 2 from the pivot. The distance, the perpendicular distance will be L by 2 minus x. And it is given there is a mass placed on the bar. So to balance this weight, the moment, you should be adding the next mass on the other side, which is at a distance y. So since it is in the balanced condition, it's in equilibrium, the clockwise moments should be equal to the anti-clockwise moments. So if you are considering that the moment due to the weight, which is the clockwise moment, will be the mg, the weight value, and the perpendicular distance, which is L by 2 minus x, will be equal to the anti-clockwise weight, which is due to the small m. So that is mg, and the perpendicular distance is y. So here you have to rearrange it for the y, and you can cancel the g value. So y is equal to m divided by small m, L by 2 minus x. So here you could see no option fits this expression. So you need to rearrange this. So we can do cross multiplication in the brackets. So it is L minus 2x divided by 2. So 2 can be taken common. So it will be m divided by 2m, L minus 2x. So the correct option is option C. Question number 15. The mass and volume of an object are varied. Which two changes, when made together, must increase the density of the object? So the density is a measure of an object's mass per unit volume. So density formula is mass per volume, and here you have to increase the density. So you have to increase the numerator and decrease the denominator, which means that the mass should be increased and the volume should decrease. So the correct option is option C. Question number 16. On Earth, a solid object that is fully submerged in a liquid experiences an upstretched UE. On Mars, the same object fully submerged in the same liquid experiences an upstretched UM. The acceleration of free fall on Mars is 3.7 meter per second square. Assume that the liquid's density and the object's volume have the same values on Earth and Mars. So what is the ratio of UM divided by UE? So the upthrust formula is rho Vg. So rho is the density of the liquid, V is the volume that it is submerged, and G is the acceleration due to gravity. So here it is given that it's using the same object and the same liquid, and it's fully submerged, which means that the volume and the density are the same. It's not going to change. The upthrust will be proportional to the gravity along, or the acceleration of free fall along. So if it is of the Mars, it is proportional to the gravity on the Mars, and if it is on the Earth, it is proportional to the gravity on Earth. So you can divide this formula. So UM divided by UE is basically equal to GM divided by GE. So we can substitute the values. The GM is given as 3.7 and GE is 9.81. So substituting these values, you will be getting 0.378, which is closely to option A. Question number 17. A student attempts to derive the formula for kinetic energy EK. She begins by considering an object of mass m that is initially at rest. A constant force F is applied to the object, causing it to accelerate to a final velocity V in displacement S. The kinetic energy gained by the object is equal to the work done on the object by the force F. Which equation does the student not need in order to derive the formula for EK? So here you have to find out the kinetic energy formula. So it's given that it is falling from rest, so U is equal to 0, and a constant force is applied. So always that work done is converted to the energy. The work done formula is force multiplied by the displacement, which is S, and that is equal to the kinetic energy. So here you can substitute for the distance using the formula V square is equal to U square plus 2AS. So here it is initial velocity 0. So it means that V square is equal to 2AS. So S is equal to V square divided by 2A. So substituting the values over here, and you can also substitute F is equal to MA. So MA multiplied by V square divided by 2A. A and A get cancelled, gives you half mv square, which is the kinetic energy. So the work done has been converted into the kinetic energy. So here you have used F is equal to MA formula. You have used W equal to Fs formula. Then V square is equal to U square plus 2AS formula. So the one which has not used is option C. Question number 18. A ball falls towards the ground from point X. Point X is 2.4 meter above the ground. The ball rebounds from the ground and rises to point Y. Point Y is 1.8 meter above the ground. A single value of the change in height delta H is used to calculate the change in gravitational potential energy of the ball from X to Y. What is the magnitude of delta H? So it is given that it is representing the delta H that single value is used for the gravitational potential energy. So here the point x is over here and it is falls down and reaches the point y. So basically the height difference is just the height difference between them. So here it is 2.4 meter and it rebounds to 1.8 meter. So delta H is just the difference between 2.4 and 1.8, which is 0.6 meter. So the correct option is option A. Question number 19. The diagram shows a block on a slope. A constant force of 1.8 Newton in a direction parallel to the slope is exerted on the block. This causes the block to move along the slope at a constant speed. The block moves a distance of 8 meters along the slope and gains height h. The work done against the frictional force acting on the block is 4.8 joules. The weight of the block is 4 Newton. What is the value of h? So here, it's having some work done in this direction. So that work done due to that constant force you can find out by using the formula Fs. So it is 1.8 multiplied by 8, that is equal to 14.4 joules. But this is the energy gained as it moves upward direction, but there is a frictional force which is doing work against this work. So there is a loss of 4.8 joules. So that loss, which means that 14.4 minus 4.8 joules is basically gained, and that is equal to 9.6 joules. So this is what brings to the gravitational potential energy, which is mgh. That is equal to 9.6. So here it is given that the weight, which is mg, is 4. So 4h is equal to 9.6, which means that h is equal to 9.6 divided by 4, that is 2.4 meters. So the correct option is option B. Question number 20. The motor of a crane lifts a load of mass 600 kilograms. The load rises vertically at a constant speed of 12 meters per minute. What is the useful power output of the motor? So useful power output is, you can find out, since the mass is given as 600 kilogram and the speed is 12 meters per minute. So per 1 minute it moves 60 meters. So you can find out, you can convert this minutes into seconds, which is 60 seconds. So 12 divided by 60 is 0.2 meter per second. So you have the mass and you have the speed, and from this mass is what contributes to the force, which is the weight. So weight you can find out, or the force you can find out with mg, that is 600 multiplied by the 9.8. Because the power formula is force multiplied by the velocity. You can use this one, and this force is the weight, which is 600 multiplied by 9.81 multiplied by 0.2, and that gives you 1177.2 watt, which is 1.2 kilowatt. So the correct option is option B.